Crossmatch. There's always going to be a number, times 2, times 1. That's how many units we're going to want. This I drew last week, right? Except now we're adding this last piece to it. Last week we went through the screen. Positive, antibody ID, antigen type, negative. So pretty much it's the same one, except negative, immediately spin crossmatch. Positive, screen, antibody ID, antigen type, and then we have to get all the way through AHG. So let's talk a little bit about the problem crossmatch. We talked a little bit about it already. Most crossmatch problems are caused by patients with antibodies. Makes sense, right? It's going to be the ones that are going to cause the problems. Antibody screen is positive. Records show a history of antibody, even if the screen is negative. So we have a history of antibody that maybe we need to test for. So one of the things we have to do is look up, determine how much blood we're going to have to type. Because we know that if I cross-match a unit, so let's say, for example, this person has an anti-big E. A lot of our units are going to have big E. What percentage of units? Do you guys remember the number?
With big E?
Big E.
Only 30% of people have the antigen.
30%. So 3 out of 10 units is likely to have it. So if I need 1 unit, should I just do 1 or should I try 2? You know, what's that number? So we have this math that we use to figure out how many units we have to use to do this. So we have to look up the percentage of blood compatible to the antibody. Some of these numbers we know, the 30%, whatever, and I'll show you a chart on the next page, and there'll be a chart in the lab this week you can look at. If the percentage is given on frequency of the antigen, we want to subtract it by 100, because you want to know blood compatible, okay? So 30% have it, so compatible would be 70%. If more than 1 antibody, you're going to start multiplying those percentages together. So this, do not worry, you can't see this back there. This is kind of what the chart is going to look like in the lab though. So it's all the major blood groups, and then what the percent compatibility of all the different groups for. And you can look this up in the lab when we get to that point. So to determine how many units we're going to screen, you take the number of units requested and divide it by the percent compatibility. And that's going to give us our N. It's a pretty simple piece of math. It'll be on the board. It's in your lab manual. So like when it comes to a lab exam, it's in your lab manual. Just make sure you know where to find it to make sure you know how to do it. So here's an example. 70% of donors are big E negative. I want 2 units, 2 divided by 0.7. I have to do 2.8. We always round it up to 3 at this point. So I'm going to have to screen 3 units to get 2 compatible, most likely. In this situation, I have a patient with anti-Duffy A and anti-Big S. So 33% of donors are Duffy A negative. 50% of donors are S negative. So our N, we want 4 units over 0.33 times 0.50, which is 0.165. So I'm going to have to look for 24 units of blood before I can find 4 units that are Duffy and S, Duffy A and S negative. At this kind, when you start getting this high, you probably have to contact reference labs, because a lot of hospitals aren't going to have like that many B negatives, for example, on staff. So this is only a guideline. This formula is a guideline. There's no guarantee. You might do that 25 units and only have 2. You might have to keep going, because there's no way to know what your stock is and which ones you grab, right? Anything you get, if I do that 24 and I get 6, I'm going to slap a label on those and say, hey, Big S negative, Duffy A negative, because you don't know who's coming in next that might need it, and now they have this little bonus that these units are there. Or if they need more than 4, if they need the other 2, they're labeled. So if you get more that are compatible, more that are negative, just label them. If you get less, you're going to have to keep going more. Now, when you're screening for antigen-negative blood, if the antibody is showing up in the patient's serum, you can actually use the patient's serum to screen first. Rather than antigen typing all those units, you can actually use the patient's serum. This is really helpful when you're dealing with more expensive or more rare antiseras. So you perform the cross-match to find the compatible units, and then antigen type only the compatible units. So you still have to antigen type to verify. But if you have a lot of patient plasma, this is an easier way of doing it. Especially helpful if multiple antibodies, because it's only 1 tube versus all the controls and all those other ones you have to do. Very cost effective if you have enough patient plasma, rather than using those specialized antiseras. If multiple antibodies are present, but they're not showing, so for example, they spike, but now they're way down here, we don't see it, but we know they have a history, always screen for the higher frequency antigen first. So anti-little c, 80% frequency, so that means only 20% compatible. We're going to type for that one first, and then just hope this is still running. So always type for the higher frequency antigen first because it's going to be harder to find this one. Then we can search these and probably find one of those. Does that make sense? So, couple cross-match problems. Negative screening cells, but the records show an antibody. So the records show an anti-JKA, but the screen went negative. So in this situation, as I said, the titer is drop below detectable. So we have to carry the cross-match all the way through Coombs, and we're going to have to type the donors for the antigen. So we want to look for JKA. We have to give antigen-negative blood because all it's going to take is a little bit of antigen for that antibody to spike again, right? Secondary exposure, you get faster and bigger response. That's what we're looking at here if we don't watch it. So we want to make sure we give antigen-negative blood if they have a history of the antibody but don't have it right now. So here's one we have. Screening records show a positive in HG. Records show an antibody. So we have a screen positive and we have a record of anti-big E. So in this situation, we can run selected cells only. There's no need to run a complete panel. So what we're going to do is select cells to run any new antibodies. So what we're going to do is select cells that are negative for the antigen we know about. So we know we have a big E, right? So we don't want to run any E positive cells because we know those are going to be problematic and positive and not allow us any cross-offs. So we're only going to set up the E negative cells on our panel, and then we can do cross-offs and rule everything else out. Yeah.
Are we solely relying on the records that say there's an E?
This is how we're ruling everything else out. Yes,
Yeah.
if we have a history of E, we know it's an E.
Trust it? Okay.
So we just say, yep, we're definitely not giving any E positive blood. So then we pick the select cells negative for the antigen known antibody, which is big E in this situation, but all other common antibodies must be covered just once, or it depends on where you're at. Some sites you only have to get one more homozygous cross-off, you don't need the two. Okay? Some sites you still need the two, depending on where you're at. But you don't have to run the ones positive for E because you know the E is there. So why waste those cells? Why waste your time on those? Just focus on the E negative cells to make sure you roll everything else out. So in this situation, known anti-big E right there. So I pick these three cells, and like in this one, I can get one out of almost all the way across. If the screening cells are positive in HG and there is no antibody shown, we don't have a record of a known antibody. If selected cells are negative, patient has no other new antibodies reported as known anti-E, no new antibodies. So we have a history of anti-E. All the selected cells are negative. We know there was an E. We can just say known anti-E, no new antibodies. If one or more of the new ones are positive, now something else is causing the problem. So because something else is the cause, now we can run a whole panel and try to identify what else is causing the problem. Anytime we have screening cells positive in HG or records showing antibody, you're going to have to run your cross-match all the way through HG. You're going to do an immediate spin, add your peg, incubate it, wash it 4 times, blot it real good, add your HG, read it, add your check cells if it's negative. Anytime I talk about running through HG, that's what we're doing. Anytime you say it says something like test in HG, run through HG, that's how you're setting it up, just like you're doing your HG in your panels, in your screens. We can use our patient serum to screen for antigen-negative donors if we need to, and we can antigen type the compatible donor units. Another one, screening cells are positive in HG, no record of an antibody. So, whoop, we got a problem. So then we have a possible new antibody, probably clinically significant, if it's positive in AHG. We're gonna set up a complete panel ID, just like we did last week. Run selected cells as needed, and then you're gonna carry your cross-match through AHG again. We're gonna antigen type the patient. Anytime we have a new antigen or antibody, we antigen type the patient. Why didn't we have to antigen type the patient last week?
We already did.
We already did, right? Because we did the anti-D and the ABORH. I did that on purpose for you last week. We gave it because we already did it there. If I'd given you an E, we hadn't done it yet. So then you'd actually have to antigen type the patient. Next week, you'll have to do that last step. Antigen type all compatible units because we want to verify that they truly are negative. And then we're going to put the new antibody information on that record to make sure that the next people doing the cross-match know there was an antibody. Screening cells, positive immediate spin, but negative in AHG. Records show no antibodies. Not clinically significant. We have no need to identify the antibody. However, we still have to carry the cross-match through AHG. We don't need to antigen type donors. Because the immediate spin is likely to be positive too, we want to prove that at AHG, those units are still negative.
I'm sorry, when it says no need to identify antibody, are we talking about the antibody in the patient's serum?
Yeah,
Okay.
right there, because it's an immediate spin.
Okay.
So we don't have to identify it, but we still have to run it through AHG. Pretty much, we run anything through AHG if there's any issues. If there's any issues anywhere up here, we run it through AHG. The only ones we don't have to, immediate spin, type is okay, screen is a negative, we can immediate spin it, no history. What we add to records in this situation is something along the lines of, depending on where you're at, they'll have exact wording, clinically insignificant cold agglutinin at room temperature. Just so we know, yep, we found it. That'll help the next person know that, yep, this was found before. Screening cells, positive immediate spin and AHG, records show no antibodies. This may be due to a strong agglutinin from an IgM. Because if you look, these IgMs are 4+, AHG drops to 2. So we have this strong, strong bond. What are we going to do? At 37, it doesn't go away. So what we're going to do in this situation is we're going to run a panel to identify the antibody. If it's a typical IgG antibody that cross-matches through AHG and antigen-type donors, one of these guys. If it's a typical IgM, we're going to have to do a PREWARM. And a PREWARM is what I talked about a little bit earlier. We're going to warm your saline for washes. You're going to wash warm. You're going to collect it and keep it warm. You're going to spin it right away. You're going to keep your plasma and your heat block. Everything gets pre-warmed before you put it together, because if you put anything together cold, it's going to bind and stick tight. So that's what these instructions are. Wash serum and cells separately before mixing. Omit the immediate spin step because we don't want the IgMs to cause a problem. We omit LIS or PEG and reincubate for a full 30 minutes because LIS and PEG actually enhance IgMs, which we're trying to get rid of the IgM here. Wash with 37-degree saline. And then at this point, if the antibody screen and cross-matches are negative, we know it's clinically insignificant. We don't have to set up antigen-negative blood, and we can report the cross-matches as compatible, AHG compatible. If at this point they're still positive after pre-warming, something might be clinically significant. So we're going to have to try to set up cross-match compatible antigen-negative donor blood in this situation.
Why don't we always pre-warm?
Because it's a pain. Because you're dealing with, like, the water bottles are kept in water baths, so you got water everywhere. Everything has to be, you take longer. Instead of 15-minute incubation, you can eat for 30. You have to pre-warm everything for 10 minutes before you do it. It does not happen often. And when it does, you're like, oh, it's happened on my shift. Because it's a nuisance. So, negative screening cells, cross-match is a strong positive immediate spin. Uh-oh. Do you remember what I said about this a couple of slides back? 4+ immediate spin. ABO incompatibility, right. Anytime you see something like this with a negative screen, think ABO incompatibility. Probable ABO problem, major ABO error. This is the main purpose of the immediate spin cross-match, to make sure that we don't accidentally give A blood to a B person. Double check blood types. Here, we have a 1 plus. Negative screen, cross-match weekly positive and immediate spin. Negative here. So 1 plus, probably not an ABOer. ABOs are 4 plus. Think your anti-A, anti-B, and your reverse typing. We're talking 3 to 4 plus strongs, right? ABOs are strong. This is something else going on. This is still probably an ABO problem, but it's probably like an anti-A1. It's a subgroup problem. Passive anti-A or anti-B from group O platelets, it could be. If only one donor is positive, it could be an IgM antibody to a low-frequency antibody. Or antigen, excuse me. If we have a subgroup of A, we're going to lectin type the patient, should be negative, serum against A2 cells, carry cross-match through the AHG. Remember I said any issues with any of this, we're going to carry through AHG, should be compatible in AHG, because anti-A1 is an IgM, it's a nuisance antibody. All of you guys that were in that open lab where we did the lectin typing and all of that stuff kind of saw that, what we did. It could be a passive anti-A or anti-B. You want to look at recent transfusions. Did they get some platelets recently? Did they get some plasma with some antibodies floating around? Do a DAT. Remember a DAT, direct antiglobulin. They're going to take the cells out and see if it's sensitized in vivo. We're going to do one of those, see if it's positive. Crossmatch is probably still going to be positive in AHG. If it's still positive in AHG following all that, we're going to have to set up group O cells until we can figure it out. And once we start giving O cells, unfortunately, we usually have to keep giving O cells. Because an IgM to a low-frequency antigen, select another donor unit to cross-match, or possibly even just carry it through the AHG because it's likely to warm out if it's an IgM. Blood type does not match the records. So in this situation, it looks like an O, but the record's showing A negative. What's causing that? Sample mix-up, repeat the test. First and foremost, first thing you're going to do, repeat the test. Did you get your racks mixed up? What happened? Redraw the patient ID record, ID problem. We're going to get a new sample and repeat the test. Check the record, see how many other times that patient was done. If it was just once, maybe that was the problem that didn't get caught. If patient records need to be changed, we're going to check with the supervisor. Chin and I are your laboratory supervisors. So if you ever find a problem, come find us. We will make the decision how to move forward. Things that happen with this, sometimes bone marrow transplants can cause it. I mean, there's lots of things that can cause blood type to change. So the supervisor makes that final call. So resolving problem cross matches, you cannot memorize every possible situation. There's no way to memorize it. This is base by base. You must rely on your interpretive and problem solving skills. You must be able to think, what next? If this, then this. Like, I could draw this out, but there's actually like 6 million other like arrows I could make of things that could happen, right? You have to use your logic and your common sense. Remember lecture 1? Every step along the way, does this make sense? Does this make sense? Does this make sense? Every step along the way. If something doesn't make sense, fix it before you move on. Resolve it. Find out why it doesn't make sense.